Merge sort in respect of best case. Suppose we have this array 30, 40, 50, 60, 70, 80 and 10, 20. As we know, in merge sort we have two sorted subarray. So suppose we have these two sub-sorted array, and these are the indexes 1, 2, 3, 4, 5, 6, 1, 2. So as we know that when two sorted subarrays are present in merge sort, then we do sorting by combining both of them. So what we are doing here, we are just comparing, because these are the division of the array like that. Here in one subarray 2 elements are there, in another subarray 6 elements are present. So we are doing comparison with this 30 with 10. We are doing 30 with 10 comparison, then which is minimum element? 10. 10 is minimum element. So then this will shift here, this will shift here. So then after that we will compare 30 with 20, because next element is 20, so the minimum element is 20. So now after that, after these two comparison, we will copy all to the another array which we called as B array, because we know this is outplace algo. This is outplace algo because we need another stack in which we store all these elements after sorting. So what will come here? 10, 20 after two comparison, and after that whatever is here in M subpart we will copy all. We will copy all here in B array. So it will come automatically like that: 30, 40, 50, 60, 70 and 80. All will come here in this array. So how many comparison occur? Comparison only 2, because of the division of subarrays like that. In that we have only 2 elements, so comparison occur only 2, or we can say the minimum of mn. N are subarrays, sorted subarrays, and movement will remain same. How many elements we have? 6 plus 2, 8. So movement are 8, or we can say m plus n. So we can simply say the time complexity is m plus order of m plus n. So a smaller number group come first, so no comparison will left. That is best case. In this case, why this is best case? Because smaller member group come first. So less comparison, that's why this is called a best case. Only because only one group person will come first, which are smaller in number than another group will copy directly. After that, there is no need of comparison because we know both arrays are sorted individually but not completely. So if one part of the array is after comparison will come here, then another part of the array we will just copy it. So that's why this is called the best case. So how we can write this algorithm? We can write this algorithm like that. Merge array index mid or mid plus 1, that is for first part of subarray, that is first subarray, and that is second subarray, then the last index. Then in that what we will check? We will check k is equal to mid plus 1 and c another variable whose value is 1. Now we will check while I is less than mid and k is less than equal to j. I is the first index is less than equal to mid, and which is mid plus 1. K, what we have assigned, mid plus 1 is less than equal to j. Then it will run, and if array of I is less than array of k, then we will shift that into the next array in the first position. So and increment y I plus plus and c plus plus, because what is required, minimum element should come first. So in that case, in both the cases we are comparing array element for first subarray and for second subarray. We are comparing whatever is less, it will come to that another array in which we are storing the after comparison. Then after that we increment both I and c. Else what we'll do, bc is equal to ak and k plus plus and c plus plus, otherwise it is not less than. Then if first subarray element is not less than the second subarray element, then second array element will come to the second array. Whoever is less, it will come to the second array. Like that we are doing comparison and it will work. And if I is greater than mid, then if I is greater than mid, then copy second group as we have did here, because here after two comparison I is greater than the mid. Then copy second group remaining to B, the next array in which we are copying all the elements. Else copy first group remaining to B. If I is greater, then second group should copy, and if I is not greater, it means first group remain to B. Then copy B to A, then close. So in that best case, this is the whole algo which we have done here. So in, we can say in best case, comparison will occur n by 2, because if total number of elements are n and we have divided into two parts, n by 2, then best case comparison will be n by 2, and in worst case comparison will be n minus 1. Total number of elements we have to compare. So this is outplace algo because we need extra array, that is B, in which we are copying all the elements. So this is the best case for the merge sort.